Boys and girls, in this lecture, I'm going to discuss creative question on the basis of chapter number 11, current electricity. Now, I'm going to discuss creative question number 1. Creative question number 1. You see, boys and girls, this circuit is given, and there are sub question. The first question is here A, what is called electric current, and the second question is here why electronic device does not support Ohm's law, and question number C, calculate the equivalent resistance of this circuit, and the fourth question is here, do you think electric power of R1 and R4 are same? Explain mathematically. You know, boys and girls, first question will carry marks 1. Second question will carry marks 2. Third question carries marks 3, and the fourth question carry marks 4. I already discussed about question number A and question number B in my previous lecture. So I think you can easily solve here question number A and question number B in my theoretical lecture part. Now I want to solve question number C and question number D. Boys and girls, in question number C, I want to calculate equivalent resistance. So before calculating equivalent resistance, you need to know about this circuit properly. You see, when switch is connected, then this circuit will supply totally I amount of current along this direction A, B, C, D. When electric current comes to at the end of point A, then you see here there are two paths after point A. There are two branches after point A. So because of these two branches, here electric current divides into two parts. One is I1, another is here I2. So the first one is here I1 and the second one is here I2. And at point B, here I1 and I2 coincide together and will produce total amount of current I. And this I amount of current passes through resistance R3. That means I3 will equal to I. And at point C, electric current also divides into two parts. One is I5 and another is here I4. One is I5 and another is here I4. So I4 and I5 coincide at point D and flows total current I in the circuit. So when these two resistance because of this two resistance current divides, then you can say that two resistance like R1, R2 is connected in parallel connection. R4, R5 is also connected in parallel connection. So these two are connected in parallel connection. These two are also connected in parallel connection, and this part and this part is connected in series connection. Now I am to calculate equivalent resistance of R1 and R2. Boys and girls, equivalent resistance of R1 and R2. You know, this R1 and R2 are connected in here parallel connection. So the equivalent resistance of R1 and R2, it must be here, let RP1. So RP1 will equal to 1 divided by R1 plus 1 divided by R2. 1 divided by R1 plus 1 divided by R2. Now the value of R1 is 4 ohm plus 4 ohm. So if you complete this equation, then you can say that the value of this RP1 will equal to 2 ohm. In next step, here R4 and R5, these two are also connected in parallel connection. So the equivalent resistance of these two resistance R4 and R5, it must be Rp2. So Rp2 will equal to 1 divided by R4 plus 1 divided by R5. Now, by following my previous calculation, here R4 will equal to 1 by 4 plus R5 will equal to 1 by 5. So the total resistance Rp2 will be here 1 by 20. This one becomes 5 plus 4. Now totally Rp2 will be 20 divided by 9. 20 divided by 9. So my total resistance or total equivalent resistance R will be, here first one R1 R2 is converted into Rp1. R4 R5 is converted into Rp2 and R3. These three resistance, say Rp1, Rp2 and R3, is connected in series connection. So because of their connected in series connection, equivalent resistance Rp1 plus Rp2 plus R3 will equal to, first Rp1 is 2, second Rp2 is 20 divided by 9, and third R3 will equal to also 2. So total equivalent resistance will be 4 plus 20 divided by 9 ohm, or you can simplify this equation. Thank you. In next lecture I'm to solve question number D and then my next creative question. Thank you very much.